Whenever we come across integrals that involve the following expressions, root a squared minus x squared, root x squared minus a squared, and root a squared plus x squared, we can be using trigonometric substitutions. This is because these expressions are related to the square identities. So just recall that the square identities are sine squared x plus cos squared x equals 1, sec squared x equals 1 plus tan squared x, and we don't use the third identity, cos x squared equals 1 plus cot squared x. This is rarely used, if at all. So if we look at the first expression here, whenever we're given an expression that looks like this, we are going to let x equal a sine theta, whatever the value of a is, right? And the reason we do this is because the expression will reduce to root a squared minus x squared will be a squared sine squared theta. We can take out a common a squared from the two terms, and we're left with 1 minus sine squared theta in the brackets. Then we have a squared. 1 minus sine squared from this identity is cos squared. So we'll have a squared cos squared theta. And the square root of a squared cos squared theta is just going to be a cos theta. A is a constant value. So we're reducing the expression by using a trigonometric substitution. We're reducing this expression involving a surd to a single trigonometric ratio. Similarly, if we're given the expression root x squared minus a squared, then we're going to let x equal a sec theta. The reason is because this expression will reduce to x squared will be a squared sec squared theta minus a squared, square root of that. So it's the square root of, take out a common a squared times sec squared theta minus 1 equals the square root of a squared. Now sec squared theta minus 1, sec squared minus 1 is going to be tan squared. So we'll have tan squared theta. And the square root of a squared tan squared theta is just going to be a tan theta. So again, we have a single trigonometric ratio. And finally, if we're given an expression that looks like it's in the form root a squared plus x squared, then we are going to let x equal a tan theta. And the reason is because this expression reduces to a squared plus x squared will be a squared tan squared theta. We take out a common a squared, and we have 1 plus tan squared theta, which is the square root of a squared. 1 plus tan squared is sec squared. So we have a squared sec squared theta, the square root of that. And the square root of all of that will be a sec theta. And again, we have a single trigonometric ratio. So you just need to identify. You don't need to remember any of these, provided you know these square identities very, very well. You can always figure out which square identity to use, what substitution to use. You don't have to sit and remember all the possible scenarios. Okay, this expression in the denominator is of the form root x squared minus a squared. So a squared is 9, which means that a equals 3. So we are going to let x equal 3 sec theta. So this equals the integral of 1 over root x squared will be 3 squared times sec squared, so it'll be 9 sec squared theta minus 9. And dx, we need to differentiate this so that we get a d theta. So dx will be 3. The derivative of sec theta is sec theta tan theta, then d theta. So we'll have 3 sec theta tan theta d theta. That equals 1 over, we'll take out a common 9, and then we're left with sec squared theta minus 1 in the brackets, times 3 sec theta tan theta d theta. That equals integral of 1 over square root of 9. Now sec squared theta minus 1 is tan squared theta, that's one of your square identities, times 3 sec theta tan theta d theta equals the integral of 1 over the square root of 9 is 3, and the square root of tan squared theta is just tan theta, times 3 sec theta tan theta d theta. We can cancel the 3's as well as the tan thetas, so we're left with the integral of sec theta d theta. And the integral of sec theta, you can look this up in the table of integrals, is ln sec theta plus tan theta, and then we add the constant of integration. Now we can't leave it here because the problem was in terms of x, and we used a trigonometric substitution and worked in terms of theta. So we let x be 3 sec theta. In other words, x over 3 equals sec theta. So we've got sec theta. We are going to need to find an expression in terms of x for tan theta. So let's just draw a right angle triangle. Angle theta. Sec is hypotenuse over adjacent. So hypotenuse is x, adjacent is 3, which means that the opposite side will be the square root of x squared minus 9. So that equals ln sec theta is x over 3 plus tan theta is opposite over adjacent, so it will be root x squared minus 9 over 3, and we can just clean that up, get a single fraction here, so the denominator is 3, and we have x plus root x squared minus 9, the absolute value of that, ln of that absolute value, plus c, and this is the answer. Just to clean it up a bit, we can take out the third, so we'll have third ln x plus root x squared minus 9 plus c, and that's the final answer. Okay, the denominator, so we are going to let x equal 4 sine theta. Whilst the integral x squared will be 4 sine theta squared, which we're just going to write as 16 sine squared theta over the square root of 16 minus 16 sine squared theta times dx, which is 4 cos theta d theta. So that equals the integral of 16 sine squared theta over the square root of, we'll take out a common factor of 16, and we're left with 1 minus sine squared theta times 4 cos theta d theta. That equals the integral of 16 sine squared theta over the square root of 16 cos squared theta times 4 cos theta d theta equals the integral of 16 sine squared theta over, The square root of 16 is 4. The square root of cos squared theta is cos theta times 4 cos theta d theta. That cancels nicely. So we're left with the integral of 16 sine squared theta d theta. We're now going to use the double angle formula for cos 2 theta, but in terms of sine theta. So cos 2 theta equals 1 minus 2 sine squared theta. 2 sine squared theta equals 1 minus cos 2 theta, and therefore sine squared theta equals 1 minus cos 2 theta over 2. So we have 16 times integral of 1 minus cos 2 theta over 2 d theta. We can pull out the half, so 16 times a half will be 8 times the integral of 1 minus cos 2 theta d theta. So it's 8 times the integral, writing it as two separate integrals, the integral of 1 d theta minus the integral of cos 2 theta d theta. So that equals 8 times the integral of 1 with respect to theta is just theta minus the integral of cos 2 theta is sine 2 theta, but we also have to divide by the derivative of 2 theta. So we're dividing by 2 plus the integration constant c. So it equals 8 theta minus 4 sine 2 theta plus c. Recall that we let x be 4 sine theta. So x over 4 equals sine theta. So we have 8 theta minus 4 times 2 sine theta cos theta plus c. So that's 8 theta minus 8 sine theta cos theta plus c. Theta will be arc sine x over 4, or if you prefer, sine to the minus 1 x over 4. And we also need to determine the value of cos theta. Sine theta is opposite over hypotenuse, so opposite is x, hypotenuse is 4. So the adjacent side will be root 16 minus x squared. So we have 8 theta, so it's 8 sine to the minus 1 x over 4 minus 8 times sine theta, which is x over 4, times cos theta. Cos is adjacent of hypotenuse, so it's root 16 minus x squared over 4, and then we have the integration constant. So we have 8 sine to the minus 1 x over 4 minus, let's multiply the denominators. 4 times 4 is 16. 1 over 16 times 8 is a half. And then we have x times root 16 minus x squared plus the integration constant, and there is our answer. Okay. This expression in the denominator is of the form x squared plus a squared. So we are going to let x equal, before we do that, a squared is 9, so a is 3. So we are going to let x equal 3 tan theta. So that will give us the integral of x squared will be 9 tan squared theta over the square root of x squared will be 9 tan squared theta plus 9 times dx. So dx will be 3. The derivative of tan theta is sec squared theta d theta. So dx is 3 sec squared theta d theta. That equals the integral of 9 tan squared theta over the square root of 9 times tan squared theta plus 1 times 3 sec squared theta d theta. That equals the integral of 9 tan squared theta over root 9 tan squared theta plus 1 is sec squared theta times 3 sec squared theta d theta. So that equals the integral of 9 tan squared theta over the square root of 9 sec squared theta will be 3 sec theta times 3 sec squared theta d theta. 3's will cancel. Sec squared will cancel 1 sec theta, so we'll have sec theta times 9 tan squared theta. So the integral of 9 tan squared theta sec theta d theta. We're now going to use the square identity that relates sec theta to tan theta. So that's sec squared theta equals 1 plus tan squared theta. In other words, tan squared theta equals sec squared theta minus 1. And by doing so, we're only going to have one trig ratio in this integral. So we have 9 sec theta times tan squared is sec squared minus 1. You can take the 9 out as a constant. So it's 9 times the integral of sec cubed theta minus sec theta d theta. We can split this into two separate integrals. So it's 9 times the integral of sec cubed theta d theta minus the integral of sec theta d theta. Now, the integral of sec cubed theta you can find by using integration by parts. We're not going to do that here. This can be found, the integral of sec cubed theta can be found on your table of integrals. So the integral of sec cubed theta equals a half sec theta tan theta plus a half ln sec theta plus tan theta, and then we are subtracting the integral of sec theta. The integral of sec theta is ln sec theta plus tan theta, and then we add the integration constant, c. So that equals 9 times, we have a half ln sec theta plus tan theta minus ln sec theta plus tan theta. So we can just write this as, we can write that as minus a half ln sec theta plus tan theta, then plus c. And just bringing the 9 in, we'll have 9 over 2 sec theta tan theta minus 9 over 2 ln sec theta plus tan theta plus c. We now need to use the substitution x equals 3 tan theta to then express this in terms of x. So x over 3 equals tan theta. So to find sec theta, we're going to draw a right angle triangle. Tan's opposite over adjacent, so x over 3, and then the hypotenuse will be root x squared plus 9. So we have 9 over 2 times sec theta is hypotenuse over adjacent, so it will be root x squared plus 9 over 3 times tan theta, which is x over 3, minus 9 over 2 ln sec theta will be root x squared plus 9 over 3 plus tan theta x over 3, and then plus your constant c. So at the bottom we have 3 times 3 is 9. That 9 will cancel with that 9 there. So we'll have a half x root x squared plus 9 minus 9 over 2. We can pull out the, no, we cannot do that just yet. So it's ln root x squared plus 9 plus x, and that is over 3 plus c. And we can just clean this up a bit. That's a half x root x squared plus 9 minus, we can pull this third out. 9 divided by 3 is 3, so we'll have 3 over 2 ln root x squared plus 9 plus x plus c, and that is your answer.